Now phosphorus 32 means we have the proton number of 15 and the mass number of 32. And when this would emit a beta particle, so beta has a charge number of -1 and mass number of 0. Since its mass is negligible and it has a negative charge, a new element sulfur would be formed. Now, as in all beta decays, the proton number would raise by 1. So it would become 16 and the mass number would remain the same. So it would be 32. The next question related to the nuclear physics. Phosphorus 32 is an isotope of phosphorus that undergoes radioactive decay. The most common isotope of phosphorus is phosphorus 31. Describe the structure and the composition of a neutral atom of phosphorus 31. Now, the structure of the atoms, and that is very similar in all the atoms. And composition means we have to describe how many particles are present in the nucleus and around the nucleus. We have to describe the composition for phosphorus 31. The proton number for phosphorus is 15 and the nucleon number for phosphorus is 31, which goes on to show that phosphorus contains 15 protons, 15 electrons, and there are 31 minus 15, 16 neutrons present in the nucleus. So I'm describing all this information. First, the composition. There are 15 protons and 16 neutrons in the nucleus of phosphorus. There are 15 electrons surrounding the nucleus. Now, in these two sentences, we have described the composition and also the structure of the neutral atom of phosphorus 31. State how an atom of phosphorus 32 differs from an atom of phosphorus 31. So, there is one more neutron in phosphorus 32 as compared to phosphorus 31. Phosphorus 32 decays by beta particle emission to a stable isotope of sulfur. The half-life for this decay is 2 weeks. State how a nucleus of this isotope of sulfur is different to a nucleus of phosphorus 32. Now, phosphorus 32 means we have the proton number of 15 and the mass number of 32. And when this would emit a beta particle, so beta has a charge number of -1 and mass number of 0. Since its mass is negligible and it has a negative charge, a new element sulfur would be formed. Now, as in all beta decays, the proton number would raise by 1. So it would become 16 and the mass number would remain the same. So it would be 32. Now, the details of the sulfur are 16 protons, then it means we have 16 electrons, and for the neutrons, we have 32 minus 16 equals 16 neutrons. So this is the composition of a sulfur atom. Now for phosphorus 15, we had 15 protons, 15 electrons, and the neutrons here were 17. So we can see that the proton number from 15 has increased to 16. So there is an extra or more proton present in sulfur, while the neutrons were 17 and now they have become 16. So neutron have decreased by 1. So now I'm writing the answer. State how a nucleus of this isotope of sulfur is different to a nucleus of phosphorus 32. It has one more proton and one fewer neutron than phosphorus 32. So one more proton means the protons have increased from 15 to 16, and one fewer neutron means originally the neutron were 17 in phosphorus, now they have become 16. At time t is equal to 0, a radioactive sample contains 3.2 10 raised to 11 atoms of phosphorus 32. So initially, this much atoms of phosphorus 32 are present. At the same moment, the sample contains no atoms of sulfur. So all the atoms of phosphorus were present and there was not a single atom of sulfur. This is shown by the cross on figure 6.1. So this is the cross which is showing that number of sulfur atoms at time is t is equal to 0 are 0. There is no atom of sulfur atom present. On figure 6.1, plot a graph to show how the total number of sulfur atoms in the sample changes with t or with the variation in time, and draw a suitable curve. Now, since the half-life of phosphorus 2 is given to be 2 weeks, so it means that initially there would be 3.2 into 10 raised to 11 atoms of phosphorus as given in the question, and they would start decaying, and after 2 weeks this would be halved. So 1.6 into 10 raised to 11 atoms would be remaining for phosphorus, and similarly the decayed atoms would have been converted into sulfur. So sulfur's number would increase from 0 to this much after 2 weeks, after one half life. Then after second half life, this would again decrease, and it would become 0.8 into 10 raised to 11, and similarly this would increase by this number, so it would become 2.4 into 10 raised to 11. The number of atoms which are decreasing in phosphorus, the same number of atoms for sulfur would be increasing. So after 2 weeks, I would be marking a dot or a point at 1.6. So it should be marked over here after 2 weeks, and after 4 weeks it should be marked at 2.4 into 10 raised to 11. Now after further 2 weeks, this becomes 0.4 into 10 raised to 11. It becomes further half, and the quantity which was decreased would be added over here. So it becomes 2.8 into 11. So the next point would be 2.8 into 10 raised to 11. And after 8 weeks, finally, this would further decrease and become half. So it becomes 0.2 into 10 raised to 11, and this would increase by the same quantity, so it would become 3.0 into 10 raised to 11. So for sulfur, after 8 weeks the point would be marked at 3.0 10 raised to 11. And now connecting all these points, we have to draw a curve. So this would be the curve joining all these points, starting from origin, connecting all the points till the very last point. The last part says, state two precautions taken when storing or moving radioactive material. So one is minimum exposure time, should be ensured that we are not exposed to radioactive materials for longer period of time, and lead shielding, like lead apron, gloves, or glasses, they should be used.